Hey guys, Josh from Darius Customs. We're here for another week on the Bronco. So we've got some spicy stuff starting to happen now. We are starting to pretty much set all the foundations, and we've completely got the front to a point where we're ready to start cycling. All the juicy components and all that stuff have come in, and we're ready to slap them on, and we're pretty well at that point now where we can get this rolling, which is a pretty big feat. The amount of work in the front end is pretty tremendous, and once we sort of get past that front end section, we start to get into a lot more quicker sections where we can start, getting engine in, transmission, stuff like that. And I guess like straight up through this episode, we're going to be looking at basically the rest of the componentry that makes up the front TTB. So we went through, you've seen the welding of it, preparing it, cycling it, and working out if stuff clears and that, like with coilovers. And now we're pretty well at that point where we can start putting stuff together because we know it works, and welding it out to a point. So a couple of things is obviously the brake kit that's come through, the big Willwood aluminium brakes that we've got here, which is pretty cool. And that goes with the spindles and everything like that. They're pretty well, they're basically cleaned, prepped, and ready for assembly. There's going to be another stage later on where we have to sort of come back to the front end, and that's going to be when we do the four-wheel drive part. So in terms of the CVs and the Dana 44 casting center that goes in, that needs to be re-geared and everything like that. So until we set that 4:1 ratio in the rear of the 9-inch and everything and work out if that's correct with our final drive ratios, that's going to be something that we're going to leave out for now. But for now, we have TTBs that are two-wheel drive and usable around the shed and drivable kind of thing. So that's what we need for now in this build. A couple of other parts, pitman arm, we're going to drop down our steering axis so we can get it better, or pretty much reduce our bump steer throughout this motion. The front section of this actually, we got 12-inch of coilover, and due to the motion ratio of how this is sitting, and that motion ratio is basically throughout your pivot range. If we had, the shock mounted right out on the end of this section here, it'd be a 1-to-1 ratio. Because we brought it in, we create that motion ratio where we do achieve more wheel mount surface travel. So on the actual external of our wheel mount surface, we do see just a bit over 16 inches of travel. So it's pretty good considering how small of a package we are running on this compared to most. So that's a pretty cool thing. Our steering system itself, look, this is something I was pretty passionate about trying to really beef it up, just due to the way that this system actually works. But the issue is that because we're in Australia, we do fall behind in some products due to American left-hand drive. Now, mainly around the steering. So because our steering is on the opposite side and everything like that, the steering links for all this system do not correctly work from America that have been made heavy duty. So we're pretty much just going to have to sacrifice that, and the OEM spec here has actually been significantly increased, which is good. So over the years, obviously, OEM people people that make OEM products and replicas and stuff like that, they've decided to make an OEM heavy-duty replica of what we need for the front end. Because our steering box is on the other side, basically you can see here we do have a bit of a roll in this, and that's to clearance around things. Now, I do a lot of fabrication, and there's probably a very long-winded way of trying to replicate this and make something heavy-duty, but we'll just see how it goes, I think. Swing set steering is not something I want to go down the path of. One, it's just incredibly intrusive, and when you're looking at it, it's not a friendly thing to look at, and it's not something you can really engineer. You are essentially creating a double pickup off your pitman arm, which means there's welding involved, or if you did cast one or fabricate one or whatever, you got testing behind that. Obviously, the way that it goes over to, it has to link in to get that swing set to basically swing both wheels. And that motion, it's not a hard motion to figure out. It's quite simple, actually. You're basically halving off that pitman arm, and that swing set over here is going to mimic that swing over here. And you're using the same Ackerman that's in the TTBs already. So it's not a complex thing to do. The only thing is that there's just so much going on the front end. And like I said, with the engineering side of things, steering is a very, one you don't want to stuff with, basically. And that is why I landed on staying with this. We don't have humongous travel, which is going to basically ruin these ball joints. And because we're doing the drop pitman arm, which is basically going from, say, this orientation to, we're going to kick down. So like normally it'd be up pretty high like this. And then as we come down like that, we are lowering that pick up on here on our Y-beam, which is going to help with our bump steer alignment, because our steering is going to stay in a fixed point, but our pivot is mounted differently. So as that traverses and moves, you're going to see your steering change in the axis, and then that's where you start to form bump steer. And we're trying to mitigate that as much as we can, because how we are currently set up, we should be near factory. So in factory specs, you would say that they've mitigated it enough in a factory driving application. So we should see that transfer to our lifted version of this, but we will run through all the figures. So we've got that, got the brakes, bump stops. We recently did a bit of scanning on the side of the chassis, made up some bump stop mounts. They do angle out. There's not a massive need for them to angle out, but it's more the bottom section where they pick up. We need to be outside the radius arm brackets, hence why they are on an angle. But what we will do is we have put mounts on the TTBs, which follow that angle of that, to try and get that outside. But the problem is that the Delron alignment and the pinch factor of it. So obviously when we start cycling this, we are going to create friction with that Delron, and where that does actually attach to it, we want to eliminate how much it keeps moving with friction under cycling of it. And that's going to be with alignment of the bump pad, obviously. So what we will do is probably get some round stock, maybe 50 mil, and pretty well just cut it on the bandsaw on a bit of an angle, and then we weld that to bring our bump pad back, and that will take out the friction on the Delron, and we'll hopefully stop, pulling that down and diminishing the Delron all the time. Coilovers, this is a bit of a funky one, okay? So it's going to be a bit more in depth when we get to it, but basically the traditional way of a coilover setup that most people would use is a dual rate coil. You're going to have a lighter coil up top, you're going to have a heavier coil down bottom, around that 100 to 150 pound difference, depending. That's very loose on what you should do, but until you sort of find that shock tuning and where you want your car to sit and all that kind of stuff, that's a rule of thumb. Now you generally run, so if we've got a 12-inch coilover, we'd run a 12-inch coil top, 14-inch coil bottom, and that's pretty much the general principle of coilovers. Now with a Bronco, for one, these cars have been made many, many times in America, around when we talk about like the suspension and everything like that. We're not reinventing the wheel here. This is something that's been tried and tested and probably on 2 to 250 plus cars from Desolate Motorsports. And they've formulated a bit of a shock package. Mine a bit different to what they would run. They generally run Kings and they run a bit different. But in terms of the spring rate, they have a spring rate that has been found to be very progressive, and it doesn't really dual rate. And basically what we'll talk about there is, we were talking about that ratio of having a 2-inch longer coil on the bottom, and generally they're pretty near that inch of what the shock is. We've got this little puppy. Now this is a little 8-inch, a 200 pounder, and then, so this will sit on top. So imagine, well, obviously that's going to be on the bottom like that, but that's how we're going to have our preload on here of our top cap. We're going to come down to our little slide, and then we're going to have that on there like that. That's our first part. Now, that is interesting in itself, but by all means, if you look through the racing industry and stuff like that, you will find people who have got this set up. It's just, in Australia, it's not a common thing you would see on what we do with our builds for road reg and stuff like that. Now, our second coil is this big dog. This is pretty substantial in length, and that's basically going to be our coil package. So the idea behind this and anything like that is obviously we don't really have dual rate anymore to a degree. This is going to be a tender coil, and it's basically going to be like a, hold that coil within its range on that cycle. We're also going to pretty much use it in terms of like the small little bumpy things that you get, not the cycling of the shock. And that's pretty much, there's a bit more into the tender coil, but it's sort of hard to explain all these different kind of things about showing a practical thing behind it. So it's really not going to do a great deal for us. this big dog is. So this is a 20-inch coil, and we're looking at about 350 pound on this one, and there's some things you need to factor into this. So this will only work on a 3.0 coilover. This will not work on a 2.5 because your spring bind factor of this compressing will basically bind up and potentially push into the shock body and stuff like that. So just because you can doesn't mean you should, and this does work with what I've got because I'm running a 3.0 internal bypass. In terms of our little nuts on the body and stuff with our transfer between our dual rates and stuff like that, they're pretty much going to be doing nothing. And yeah, it's going to be interesting to set this up because technically in its raw state here we have 28 inches of uncompressed coil length. But in our rate that we would put on the front there, you'd probably see like 26 or something, or 24 depending on how it all sets up. So we do have a spring compressor. We will most likely be compressing this down to get onto the shock body, and then we will set that up. In terms of our bumps, these are our Fox 2.0 frees. This is something I had laying around on the shelf, and we've used this in this build. In most circumstances, you wouldn't really use a 3.0, maybe more on the back, not so much the front. So basically what we might get to the point of doing is knocking some spacers up to reduce the amount of travel that this has. So instead of this coming out 3 inches, we might put a 1-inch spacer in there and actually reduce this down so that we don't see so much of that actual travel within that. And that just sort of stops the engagement. We don't want to be driving around town and, you know, our first inch of travel takes us onto a bump zone, you know what I mean? And we'll have a bit more than that, obviously. We've got a fair amount of up travel in this, but that's why I said, like, we just need to see where they sit, because if we're going to be cycling and constantly hitting that bump, we don't want to be taking away what this shock is doing because we've got a bump engaging already. And you got to remember this too already has a form of, you know, bump zone within that shock setup. So we don't want to have the two fighting. We want this to be like our last resort. We need to stop this from basically mashing up our suspension and our shocks crushing. So what we're going to do is we're going to get into the front end, tear some things down, and pretty well just start assembling. We should get to the point, I reckon, within this episode of actually getting it out the shed and sort of see that car in its raw stance, and I reckon it's going to be a good thing. So we're down here on the passenger side at the moment, and I thought I'd talk about a couple of things we just mentioned. So bump stop mount, you can see the angle and the pad that we're sort of hitting here, and that was pretty Mickey Mouse how that all worked, because it integrates around everything and still has provisions for everything, and very strong too. Like, it's a big 10mm plate that we've got there. The bracket itself, we scan the chassis and use bolt holes to index, and by indexing I mean like the alignment of this actual bracketry. So we can make something pretty much symmetry both sides by using some form of reference on the chassis, and these bolt holes here pretty much reference at both sides to be bang on. So everything is pretty well not losing any kind of travel or any kind of bind or anything like that, because everything is so symmetrical, and that's such a big thing you want to get on these builds. So that's one thing that we need to pretty much just address here. You can see where the bump stop comes down here. What I'm looking at doing is potentially putting a little bit of flat round stock there on a little bit of an angle, just to sort of pick up that Delron engagement and reduce kind of friction on that. It just sort of preserves them a bit more. They're not super dear either, so if you're not racing, you're probably not going to see these smash out too much. One thing I've been waiting from, this come from America, these are cam alignments, and basically these go inside your ball joint. They are a pesky thing because they do seize up and anything like that, but what they do achieve is pretty good. So these can see a difference plus or minus of 2.5 degrees of camber, which is pretty good. That's something we need in this, and the reason why I wanted these is, one, we do have the alignment, which is good, because once we make something fixed, we want to have that provision for road use to keep aligning something if it does change. Everything between its tolerances and stuff when you buy it is always going to keep throwing out numbers on things. But the other thing too is that we don't have to really cut and turn this. And by cutting and turning, I mean we actually chop this out, bring it out, pad it, and then weld it. And that gives us more camber at a ride height instead of actually doing anything funky with our beams and clocking them or anything like that. So these will get never seized and then put in. They have a whole Ouija board of bloody things on top of here. So all these numbers and all that kind of numeric stuff, and that is basically an alignment. So you can run off a sheet here that they do give you, and this would be for the common person that doesn't know how to really pick that up on. Obviously, you could use alignment tools, or we could just basically do this with an inclinometer. So if we have a 0 point of where we're sitting, there's no reason why we can't use our spindle in a seated position of static ride height and work out that ourselves. Like we might be 0.1 out maybe or something like that, but I reckon we'd be pretty close. So basically these will lock in, and the top section of this you will turn, and as you turn it, that will basically change your ball joint trajectory for your kingpin inclination, is what it's generally called. So these top sections here, as they do dive through, is called your kingpin inclination, and that is basically the steer axis of where that is going around. That does have a lot of reference to scrub radius too. So basically where your hub is and stuff, and your kingpin inclination, and where those do traverse and meet each other, is going to be your scrub radius factor. And scrub radius is a very big thing, especially when you come to performance cars and racing. So that's something there. So the other little part I would like to sort of get to is, obviously we're going to put this full car on weight, and the last things we do need to address is basically the coilover tower. So the back section is where we've got this straight tube coming down. Where that sits there, we need to pretty much get the sawzall in there and chop 6mm out and tap a little fish plate bracket underneath there, weld that in. This section here needs to be welded in, and then here is where we need to make some funky brackets to sort of suit, just because this setup is mainly made for a left-hand drive American vehicle, so we're just trying to marry that in. We will then drop this down and we'll get our coils loaded on there. Don't know how much we'll have to preload the coils to get it on. Obviously they are longer than our stroke, and then we will sort of get semi-preloaded just to sort of get the height and get the vehicle sitting where we need to. And with the TTBs themselves, we will actually finish that welding process out and paint the whole thing. And then we'll get to steering, and we've got some things to get through, you know. And that's the thing with this stuff, is like, it's all those little things that just take so much time, but it's looking very nice, because the time and effort shows, I reckon, when you do this kind of stuff. It really resembles how much someone went into it, and you can look so far, it's very clean, and that's something that I really do pride on my workmanship, is taking that time to go that extra step for something to look good and nice and clean and functional, not just it works and it's cool. There's a difference between, you know, a different range of people and how they make things, and that's somewhere I like being, is that more meticulous kind of person. So pretty well what we're going to do now is disassemble this stuff and get the beams out and finish off welding them up. Just finished up on the welding of the beams, and they're currently drying on the rack with some steelite on it, and I thought, why not take that time to get into the steering. So Broncos, when you actually lift them up, they start to suffer a real bad bump steer, and that's mainly because your steering alignment's out of the actual pivoting motion of the suspension on the front. So over its distance of travel, your steering is changing its trajectory versus what the actual arms are doing, and that creates a thing called bump steer. How we mitigate this is obviously try and bring it back to factory steering, which is going to be dropping this pitman arm down. So what we've got here is a 2-inch drop down pitman arm. We're not going to do anything funky with changing tie rods out. Like, I'd like to increase the tie rod to a bigger one than, you know, the standard ones we are running, but that's something later on down the track. For now, we're going to stick with what we've got, which is a whole new steering system, but it's just going to be OEM, you know, heavy duty. So I've gone through, already given this a bit of a love tap, so everyone knows how hard pitman arms to get off. They generally are up torqued of like upwards of 300 newton meters of torque. So by all means, it's not an easy thing to get off normally. And well, that one just fell off. But you can see that was a bit of a task to get off. Ideally, if you don't need to do it on the car, put it on the bench, and it's probably a lot easier. So we've taken that off, and some pitman arms have this, some pitman arms don't. The inside of the indexing of the spline actually has a couple of keyways. So the way that this goes back on is sort of clocked in an orientation, and you can't really fight that. So depending on how you set your steering, obviously what we're going to do is put this on, and in most circumstances your pitman arm, because it's a forward-facing pitman arm, we're going to have 0 point when our steering wheel is at that center point of throw either side. So what we'll do is we'll put it on, go to the steering and go all the way to the left, then go all the way to the right, and as we're doing that, count how many rotations, go back half those rotations and see how this sort of sits on the orientation of that. If it's out by an index or by a keyway, and then we can go back to that, and we call that center, or we'll call that true. I've got the steering wheel sort of center point now, and I'll show you what I mean. So if we go from here and we sort of count it, we got 1 revolution to the left, and then go again, gets halfway like that. So if we go back halfway, and then we go full revolution back, that's our middle point. Then we go 1 revolution to the right, boom, and then we go again. That's our middle point there. So half back, full revolution back, and that is basically our center point. Now, as I was doing that, I actually worked out that the swing ratio on this does have a stop point, and that's actually about here on the pitman arm section. So where that sits now currently is 0, because before we had it sort of pointing straight, and we thought that was, well, presumed straight. This doesn't swing in that ratio, so which makes sense because I mocked up the steering a little bit, and one collar on the rod end actually had a hell of a lot more in it than the other. So this works out well for our short side and our long side. Yeah, pretty much going to chuck on the bottom section now of that tie rod and attach that to the diff on this side. And then we're going to work through on getting this TTB all done, and I'll show you the assembly of that. After spending a fair amount of time on this power steering box, I've actually come to the conclusion that the pitman arm is actually wrong too. So not even the point of engagement where it's sloppy, the actual phasing of it. So the motion between stops on this steering box, on this pitman arm, which is factory, is actually different to the one that's been supplied, which is extremely annoying because this is not a... I wish they didn't index it because then I could clock it where I want it. What they've done is, if you can sort of see where that flat line of, there it is, that there is what we call a keyway, or part of that indexing, and see how they're around the ring. So the phasing of this actually puts it clocked out wrong, and what that does is it doesn't let you even get it at a center point where this will even attach on the steering rack. So it's not having a good run at the moment with a couple of things, and even like the cam lock that we were talking about at the start of the video, pulled one of them out of pack, put a shifter on it, like so soft it's not funny, and snap the edging of it. So a couple of things I need to complain about, and this is the cost of doing business, I guess. But yeah, it's very annoying that the phasing on this is out. So it's either something I can change inside the box and maybe rotate the sector shaft or something like that, which that's just more work than I really should have to be doing, or once again, more work than I should be have to doing is I make my own pitman arm and phase it the way I want it. So basically reference off what we've got, create the 2-inch drop and go from there, and probably make it out of some 4130 and heat treat it. So that's what we've come to the conclusion there. Not everything always works out, and I think it's good to sort of show these things too, because we don't need to have a picture perfect world where everything's Mickey Mouse and always happening. This is stuff that is good learnings, and you pick up from this by passing this on to people so they can look at this and understand why stuff's not working. And that's the issue. The phasing on it is wrong, and the broach that's been sent through this is clocked out incorrectly. Here's my analogy on this, and this is what I reckon, is that this is for a left-hand drive vehicle in America, so they've phased it to be this side, which would probably get the center point. So it's probably not their fault. I dare say the steering box in its situation, I thought the way that it sits it should be the same, but I guess if that sits that way like that and then we flick it to this side, we're going to be phased out, aren't we? So it's probably something to do with that. I need to ring up and ask about it, but yeah, worst case scenario, we're going to have to make our own, which is something I'm really been trying to avoid with this kind of car. Is I'm trying to use stuff that we can just sort of get happening, I guess, and get it all in. Like these bump stop mounts here I made, scanned the chassis and made all them up. Stuff like that I'm happy to do, but pitman arms is not something I really want to do. So this is the issue when you try and modify something that's OEM and you don't just fabricate everything yourself. So like if we did swing set steering here, none of this would be an issue. And that's just the fact of it. So anyway, I'm going to swing this next beam underneath here and assemble it up and get the steering on it, and probably look at basically putting this coil in on this side for you. So you can see we've already got this one set here, and it is not an easy task actually getting it in, because it is a lot longer than what the coilover is. So that's something very interesting. I haven't bothered with the lockout nuts here between your transfer of dual rate. That's something we'll have to see what happens when we put weight on the vehicle, but they won't be doing a great deal. So we'll shoot in and get this beam in. Righto, so by all means this is not the funnest of parts, but it's a bit of an intricate kind of assembly, so we'll quickly go through it. We'll do it in real time too, because I don't think it takes too long. I've already pre-done the bearings with high temp bearing grease and packed them up. I'm not like going to town and fully packing these out, because I will have to take them off again. It's just enough to sort of stop moisture and you know, keep them lubricated so it doesn't move around and stuff like that. But basically we've got our beam back on, bolted up all nice, and our first point we're going to do is our cam alignment. So basically this little puppy here, as you can see, that would slip in there, and it does have a rotating assembly within that. As you rotate that, it will change your camber alignment within it. So like I said, 2.5 degrees plus or minus. And what we need from this is basically as much as we can at the moment, and then we sort of toe camber back from that, depending where we sit at ride height. So the inside of this I've kept pretty clean, and this will have to get tapped in there obviously. There's 2 aligners on there like that. So what we're going to look at doing is chucking on some never sees. These are not easy to get out. So what I might actually do is we'll put it inside the joint, save us touching a little. It's obviously going to push out a little bit once we do that and send it home. But doing this stuff is going to help me later on, because I'm not selling this car, so I'm going to be doing the maintenance on it. So what we're going to do is put the cam alignment pointing towards us, which is honestly going to push the ball joint in a different direction now. So if we have it this way, it's going to pull the ball joint that way. So if we push it this way, in its alignment, it counteracts the direction. So if we apply it that way, the ball joint's going to go this way in its trajectory, and then it's going to push the knuckle in, which is going to give us more negative camber. And that's the key here. This one looks a little bit tight, so we might have to looks like it wants to bite in a little bit. There we go. So like I said, we need to get it aligned. There is keyways on it, so it will align up, and that's us there. So that's probably going to give us our maximum degree of camber at the moment. Then we've got our top castle nut, and then the bottom one's an internal nut. So I had to get a special spanner for this, pretty big. I think it's like 1 1/8" or something like that. Just because once you see these in there, you can't really put any kind of socket or anything in there. So that's that reason. Now we'll clock this because we already know it's going to be tight as we go in. And we'll come up from the bottom, like so. Align that there. Buska. Put that on top. Now, this is something I'm going to do which you don't have to do, and you shouldn't do, but because I know I need to come back to this, I want to make it easier. So I'm going to put a little bit of never sees on the ball joints. Now, you don't need to do this, and you probably shouldn't do this. The reason why I'm doing it is because I'm trying to make my life easier throughout the build on taking stuff off. I don't need to send this home now and seize it up, because these are not cheap ball joints. So what we're going to do now is a bit of make it easier for Josh later on, if we want to call it that. Don't come at me in the comments and go, don't put never sleeves on the ball joints. You shouldn't be doing that. Well, I just told you the reason why I'm doing it. Boom it down here. Pull that spindle around. So now, we'll chuck this up. And like I said, building hubs are they're not a fun thing, and they're not a very exciting thing either, so bear with me, guys. I know it's not the most fun you've ever seen me do with you. Get this all off. I tell you, I much prefer the copper one getting all over me than the zinky grey one or whatever it is. So now we're going to pretty much send this up. Like I said, I'm not tightening them yet, so we're just going to... You love that I'm using expensive soft jaw Nipex vice grips to do up a castle nut. Most people would shoot me for this. Soft jaws are generally used for stuff that needs to basically remain its shape and not deform and get any kind of abrasion or something. And a common place you would use this is like HA glands in electrical. No, it's a bit off topic, but this is sort of, these are used to basically not cause imperfections on things. All right, so like something like that's going to be enough for us to just basically put weight on this car and do what we need to do. Definitely not driving, because we need to get the torque downs and stuff like that. So get that in there. Yep, inch and a 1/8. You can see how annoying this is and time consuming. So I'm going to tighten this up and we'll resume when we start to assemble the hub. Alright, so here comes all the fun parts now. What we're going to do is get our massive big hub, like so. And we're going to put this bearing in first. So just spread my fingers and drop that in. Yep. And then we'll slide on the spindle snout here. And you want to really be careful not to impregnate your disc brakes. Obviously, this is a bearing grease and it's not something you want on your brake pads. So get that in there. Just need to work that around now. Oh, there we go. I'll put this up here so we're not fighting gravity. Oh God, I tell you, some things on this car have been a bit of a nightmare. There we go. Oh, sweet. Now that's on there. We need to put our locking nut on. So this is so interesting, this. It's a keywayed ratcheting locking nut. So basically, your tool releases the cam inside there, or the ratchet, and it basically does up, and then once it's tight, you need to depress the ratcheting clock in it so that it can come back out. So the keyway is at the top here. There we go. It's a really hard thing to start, but don't go to town on it either, because very fine threads on these, and once they cross thread, you'd say you have to get a new one basically. You can get a thread file on them and fix them up a little bit, but not something I would be doing. Alright, so that's started there. Now a special socket, this one here, prepared earlier. And this one goes inside and basically pushes that cam down. So, get our little tool. Now you need to put pressure on it so that it releases the cam. And you hear it starting to ratchet. Takes a bit to start forming this all in and pulling the bearing pack in. So don't think that you're doing it forever for no reason. There we go. Hear that click? So that's that in there now. And we clean that up as we go. We do have a snap ring groove in here, which we'll show you now as we put in our alignment puck. So this thing here, basically, this is very common on a unit bearing assembly. Not the actual look of it, but how it functions. It's basically a step down spline. So generally on a massive big unit bearing or something else like a full floater, you can step down your spline outer cup down to your internal, which is where your CV would pick up. And a lot of these old American diffs and stuff have very different forms of this. And obviously that grease is there, so we need to push that down a bit. Probably look at giving a good old tap there. Now our little snap ring, which is this part here, we'll just start at one edge, click that in. This one in here. Now, because this is all nice and new and everything like that, that works pretty well. I'll tell you right now, on an old diff, that does not do what I just done. And now you would be thinking, okay, we've got that puck that floats in there, but how's it retain? So when you send your CV through this, they do generally have a CV groove in at the end of it for the circlip. That's what holds that in. And then now our last part, which is our worn locking hub. So this assembly here, little spring just there. We'll go through, we don't need much. A little bit on the outside here. It's always good to make sure your O-rings are lubricated because they will perish otherwise. And this does have a locker or a keyway in it too. Everything's bloody keywayed, so we just gotta get that aligned now. Just make sure it's concentrically in. It's not, so I'll pull that back out. I don't like how that went in. But basically, we will line that up now, which is just there. We've got these really tiny Allen keys, and one thing that annoys me a little bit with all these builds, obviously we need to have a cap head Allen key to put these assemblies together, but just the heads on them, they just break down so easy, and I'm not sure if it's because the bolts they use are such a low grade. If they use like a 10.9 or higher or something, I would assume the heads might maybe stick around a bit longer. But I've already had some issues with heads being rounded off. I do have a set of TTBs outside that are fighting me with actually removing all this stuff. So pretty much I'm going to go through, tighten these all up, and then we can assemble our coilover spring, which is pretty deadly. So we'll get this done, and I'll show you my depth certificate on a bench basically. Righto, so we're up to the real fun part now, which is basically putting your life at risk and using a spring compressor. So because we have 28 inches of spring on a 24-inch-ish kind of shock travel, we need to basically pull 4 inches or 4.5 inches out of these coils so we can put them on. So we're going to go through and assemble them. Now, where you pinch this coil, taking in mind obviously the shock body and everything like that, we do need to try and pinch it down small so that we can slide it on and not undo the shock, and that coil rate binds on this. But basically, first up, we'll get our tender coil. Now, I probably could compress this one because it is quite easy, but the way I was going to work it is pretty much the bottom section of this, and we'll see how we go. Now, this runs this splitter here for our jaw rate. It's like a slider. Over time, they do pinch. So you can imagine that gravity there, and as these do go up and down, they do turn. AGM, which is like a German engineering company in America, they make a really cool one of these. Some people put like slides on top, like a big washer, to try and alleviate that, but that's something we can come back to. So we chuck this on here and get that all the way up to the top. Now we'll wind these down a little bit, which is going to be our dual rate separators for where this does transfer to going to the lower one. Just basically sort of get them a bit lower so we can adjust it on the shock without trying to put our fingers between too many of them. Now this is basically retained all by an O-ring, which is pretty crazy. We've got some little seats down the bottom there which recess into the housing of the rod end, and basically are retained externally by an O-ring, which is, I think, pretty crazy. Some brands have different setups on that too. So now we've got that there, chuck this up like so. Pull it out as much as we possibly can because we need it. And here's the fun, not fun part. I like to have the branding pointing down too. I guess most people would probably like that. And now we need to find that pinch spot. So like I said, with this, we do need to compress it. And if we compress down here, we're going to have less chance of pinching it there. So I don't know if we get that spring rate completely down, but we'll try and get a bit less. So I'm going to bring that in a little bit. A 22 mil. I'll chuck this coil down here. See how we go, that might be all right. These do have little seats in here, so it does sort of hold the coil. This is where the fun part comes. Wow. Now, it would have been nice to pinch a bit more, but because we got to slide this on here, we want to make sure. Ooh, I think we've nailed that. We've done well. All right. Get that on here. And we obviously don't want to put too much pressure on knocking this bloody spring out. It's pretty scary right now. And trust me, this is not something you can do on the car very easily. So that's worked out pretty well. We'll put our cap back on. And obviously, if you did have a spring riser on this, your coil rate and distances would change. So this 20 would probably drop down to like a 18 or something like that if you were going to try and run this rate. You might pull an inch out of each or something. It really depends on the selection of coils you've got before you go custom. And that's something a mate of mine, Josh Hill, we were talking about this, and obviously the rates that I sort of were going to use at the start weren't really in that coil range. So I did reach out to Desolate, and they were pretty open on what they have done with shock tuning, and this was something that they suggested. I'm not going to say this is perfect because we don't know how the car works yet, how it sits or anything like that, but this was a rule of thumb they gave me, and look, they've built a lot. So I am going to believe them. Now these little clips go down the bottom here, like so. They are very pesky. And then we've got our little O-ring here. So put that over the rod end. We feed that over that section there, and basically work that around. That's us there. So now we put this back over, all good. And now we can start to slowly reduce this, because we do need to seat this bottom section. Yeah, that wasn't so bad, was it? Like I said, having proper tools does help too. People do straps and stuff like that with these, or maybe the press themselves. not something I'd be doing because you can't capsulate it too much. This set here cost me, I think, about $170. It's not like a fantastic brand or anything like that, but they're all pretty much the same if you go on there. Most of the big companies out there just throw their name on stuff and send it to. So have a look around, but the reason why I like this one is because the actual coil twist is not dramatic and like these. So if you've got something that had a massive spring rate that had big separation in it, they do have different adapters and stuff like that, but this would sort of struggle, and this works well for this because the further we have that like that, the more it's going to want to pop that coil out. Pop the coil out, and we don't really want that. So that's something that I factored in when buying it. But now we're at that point where we can chuck this in the car, really. So we're going to shoot over and jam this big girl in. All right, this is pretty heavy when it's fully done up. Slide this in. It does help when mounts just work. So that goes there. We'll just rest it down here for a second. Get these nuts on the back. We've got the jack underneath now, and that's really going to help us align this up. So there's a little bit of clock in the actual rod end bottom, and that's something we just need to, it's going to happen because of the way it's mounted and everything like that. So come down a little bit, and we want to start at the top like that, and pretty much get a big old screwdriver. Another thing too I'm pretty anal about is orientation of bolts and stuff like that. Everything is symmetrical on how I do it. So come here like that. Now, I did say we have to clock this a little bit. Like that. Which sort of sits us pretty nice. And then what we are going to have to do here is give a little bit of a pinch. So those good old multi grips that I was demolishing before, because these have a O-ring between the stack of the misalignments, they naturally want to push out a bit. So if you just come on here and compress them a bit, next one, push them in like that, and now they'll hold. We're pretty good now to start coming up. Like I said, it's not the easiest thing. We're going to have to actually pinch that to keep them nice and then come up with that. Oh, there we go. Okay, now we can take that out. And probably about, about there. How are we looking? A bit forward. All right, we're pretty good. There we go, straight in. That's us there. And now, that over like that. Now we can come down. One thing I've actually thought about that would be really nice is that do all this work and painting and everything like that, fabricate all the arms, but a lot of the time when you mount a jack on there and go up with it, you start to scratch the paint off, and that is actually weld a little pickup for a jack on there, just so you sort of take away constantly scratching these, because it's on an angle when you go up, it doesn't want to push the jack and sort of gouge into it. Bit of food for thought, I guess. So that's us pretty well locked in there. And I give you a little bit of a look-see. So, like, obviously I've taken this apart so many times and welded and all this kind of stuff, and it's to get it perfect. You can't just weld this stuff fully out. There's so much range of motion all in it, and I guess it's just all those parts you need to factor. So now we've done this, we can pull out and this is our steering that we were doing before. Bring that down here. So now what we're going to do is probably bring our TTBs up to a height of around ride height and sort of get the steering located on this. Then we should be pretty good to chuck a set of tyres on, I reckon. So I'm going to do that. I'm going to set this up and get the steering locked in. We're finally up to the exciting part. So the Hemi, this is the thing I've been wanting to try and jam in for ages, but we had to be patient. It's pretty much getting ready to slap in there now, and we are going to do our scanning. We're going to do this a smart way, really. So we're going to scan the bottom of the chassis and try and form up, you know, that reference, and then we're going to scan this engine in its most minimal kind of application, I guess. I will float the engine in there first, just to sort of visualize how it sort of looks, conceptualize it basically, and work out what we can do. And that depends how we use the mounts. Now the mounts on these are a vertical down, and they sit on a bushing with an Inconel shielding in it. So pretty good, but in terms of the application we're going to use this for, they might stretch and start tearing all the time. So we do have some really nice heavy duty Dom tube ones with a 5/8 bolt that we can produce our own bracket off. So that may be easier because in the sense of you pull that 2 5/8s from the front, that engine's out straight away. Really simple, but we'll evaluate that. So at the moment we've gone through and started tearing this down. You would have seen previously it was very bulky and it had a fair amount going on. It looked like a ginormous engine really, but in a sense it's not. It's pretty much the same packaging as an LS. So we went through, took the radiator pack, condenser and all that off, and then we've gone through, started taking some plastics off, some heater hoses, transmission feed lines to the oil coolers, and we're starting to really narrow this down now to the point where we can lift it and then drop this K-frame off, and that will really open us up to a lot of surface area and basically a lot lighter to put this in. We do have the 8 HP still on the back, and as for the use of that yet, still on the fence if we use it or we don't, but it's very similar to a 4L80E. So at the moment we can use it to basically see alignment in the tunnel, and the tunnel in this is very big, so we'll be pretty good. But we will use that as a reference and then we will evaluate if we use it or not. So like I said, gone through, stripped shit down, pulled engine harness stuff off, ECUs off. We're not using the one that come with this. We have a special one to go on it. And yeah, all the lines and stuff like that we don't need, that is hanging everywhere we don't want, they're gone too. Little thing I'll pass on, a little tip here, is basically with the engines, like obviously they hold the water through the jackets and everything like that. And then you got to lift this up, take it over to your nice clean engine bay that you're about to put this in, and it just puts fluid everywhere. So let's be smart about it. And I thought, look, thermostat out. We've got our lower section down here for our radiator feed back in. And then we got 2 little ports at the back here for your heater hose. So it's pretty much depleted now of fluid, but I thought I'd show you, like you get an air compressor at home and, you know, sort of jam your towel in the thermostat, hold 2 back portions of this, and see how that shoots that out? We're pretty much just cleaning out all the jackets in this actual motor assembly, and that will mean that all the fluids are basically gone. So when we got to put this engine in the bay, we're not going to put shit everywhere. So little things like that. But yeah, pretty much up to that point now where I'm going to chuck on the crane attachment or the engine crane attachment to get this leveled. And the level is good because it helps us get that degree that we want on the engine. And that's something I will go into as we further on through this build, is why the angle of the engine is crucial in a car. It's not just put it in there because it fits. There's things you need to factor in throughout the whole little portion of the building of this car. And I will pass that on to you, basically. So I'm going to shoot through now, hook up this engine assembly, finish finally getting this out, and then we're going to take it over there and start to see what it looks like in a mock-up assembly.
With an ego, yet so humble, I'm a fighter in the jungle, never giving, never crumble. I'm a hero, never stumble. Sticks and stones may break my bones, but they will never take my soul. I'm trudging down this.
How bloody exciting is this? We've got the Hemi floating in the engine bay. Now this is a pretty big step and something I've been really trying to work up to. but I didn't want to just go and rush it, and that's why we've done all this process and all the suspension and all the prep on the chassis, and now we're at that, you know, good foundation to start putting this Hemi in. Now this engine is massive. I did not measure it. I didn't take into consideration the size or anything like that. All I could really base off was the fact that an LS is pretty similar in its overall surface area. So all I really did was just, you know, obviously the heads are a bit different and stuff like that on these, and that's what gets that real nice, you know, kind of engine sound and everything that these do. But yeah, like as you can see, everywhere is pretty tight. The top section here clears, we have clearance on the side, and then underneath the section here is a sump where it's not the best sump for it, but it's probably not the worst either. So where our drain plug is pretty close to where the actual subframe is, but that's just things we can manipulate. We can relocate it, or we could scallop out the chassis and do something with that, like the cross brace. In terms of really the most critical thing to look at in this, okay, there's three things in my eyes that we need to really consider. One is steering. So our steering comes down through the column, and as that goes through that shaft down to our steering pump, there's not much we can do there to alleviate where that sits with the engine. Like it needs separation, it needs gapping, and it needs to function, doesn't it? So that is number one thing where we really can't do much. Now, Broncos, F-trucks, all that stuff, most of the steering pumps are on the inside of the chassis. If it was on the outside of the chassis, different story. But you just push the issue somewhere else on something, you know, not working. And most of the time, that would be your suspension. So our coilovers have a real nice big lean sticking out, which is super good for stability. You go to a patrol or something like that, we lose that stability because of our, you know, stance of our coilovers, but we do gain the steering being on the outside. So one thing to consider there. The next one is the sump. Potentially we could fabricate, or we could buy one where the actual main sump pickup is in the middle, not so much a dump on the front. Now, being this a K-frame and the steering rack and all that stuff that is originally on a 300C Chrysler, they would have been accounting for that rack, the sump sitting forward and the rack sitting on the back. And that is why this looks like this. So by all means, we can modify that in a way, but it sort of works too. So I don't want to keep spending money for no reason, so we can evaluate that. Also too, the only reason I would really touch it now is if we had to lower the engine, or the steering rack cycles up too high on full bump. That's something we need to look at. Also in here too, where we actually have our diff puncum, does cycle up. So just because we're going to start getting our mounts done and having it tacked into place, by all means does not mean that this is going to be, you know, good to go. There's so many things to factor into this. There's your suspension, your clearances, your heat saturation stuff. Like our extractors could be a bit too close to the steering, and that could boil things. So there's a lot of things you need to take in consideration. Also too, our bonnet, like they do have a pretty big bonnet, but our engine is starting to lead up a bit. And as that leads up and our bonnet leads down, we're going to have a little bit of issues potentially here. This cross brace, I actually had to flip and point forward instead of back. Now, I don't know in their design station, like, you know, their design theory or whatever, if they accounted for that to be back because the bonnet comes down. So that's something I have to find out when we go to test fit this, because the actual cross brace here, if it's flipped on the other side, the valve on the back here, or the breather for the crankcase, is right on it, mushroomed up, doesn't work. So look, I don't want to get rid of this, so we're just trying to work around that at the moment. As for the chassis and stuff like that, the C-section, the extractors are very close to it, but they do work. So that's one thing. Moving on now that we've got this in here, I've set the back tail shaft section, so where the gearbox comes down or transmission, we've set that around 400 to 410 either side of the chassis, so a little bit of play there, but we're trying to set this and take our markings and that for our brackets in a state of non-stress, basically. So we don't want to make these brackets and then we go, oh, we can't get the degrees on the back of the gearbox, it's like 10 degrees, we need to get down to 6 or 5, and then we got to squish it down and preload those bushes. It's just something you don't want to do because that's premature failure, and we want to put this in at a state where everything is at a zero state with no mass on it, basically, of you know, torsioning or anything like that. So the only one thing I will bring up now is that we do have to offset the engine ever so slightly to the right, and that's just for the steering. There's no way around it, and you'd be surprised at how many engines aren't actually dead center of a vehicle. We do talk about center of mass and stuff, and you know, what do you call, like your plane of mass through the car and stuff like that. And look, everything you can keep in those kind of things as like weight all the way down, stuff centered and that kind of thing, really helps with all that when you're doing stuff like jumping or racing and stuff like that. Most cars, you're not really going to notice it too much, but where you put more weight is going to create an inertia imbalance and stuff like that. So just little things like that. But look, 30 mil with an engine offset's probably not going to do it. And it does preserve the steering from getting stuffed up. Now, fair amount of effort to do these engine mounts, and I don't think we're going to jump into it in this video because I'm going to either do a bit of scanning or a bit of cardboard. Now, can only get the scanner in there so well until it doesn't really do much because it's too close as a focal to it. We could take this whole engine out, scan the engine, and then scan the whole chassis and put it all in there and try and get it all manipulated and well. It's a lot of effort. I'll be honest with you, by the time we actually get this back in the computer and we render it, do all that, manipulate the mesh and all that stuff, it's going to take a good couple of days. And at this point, I reckon the engine mounts that we're going to look at doing, so these are from TMR, and they're very common in what they are. They're basically like a shackle assembly. They call them an unbreakable mount, but I like the TMR ones purely because of the dom walling on this, the bushes that they use and everything like that. It's a 5/8, so it's a pretty big bolt versus other people that use them in what they manufacture. Also too, they do sell inserts, and the inserts are like basically an aluminium insert, so you can weld these out without cooking bushes, and that's a beautiful thing. So one thing to take into consideration there, look, I understand that these are very well at transferring energy back through the chassis, and you can feel it. I'll be honest with you, look, the OEM mount in my eyes, which is a dome mushroom that sits vertical, is not created for a Z-axis movement. I understand that cars are designed to, you know, account for certain things, but a 300C Chrysler is not something that you account for jumping or going across a desert floor. Now, that bush is not encapsulated. I'm not going to run chain to stop my engine from twisting once it breaks a mount. And one of the mounts I already took out is fatigued and stuffed, which means in its everyday use, it's already done an engine mount just driving around on an X and Y horizontal plane, and that's where we're at. So this is the mount I want to choose and use, and obviously fabrication comes down to that, which is a lot easier. So pretty well, we're going to go through now and sort of mock it up with a bit of cardboard, and once we've done that, we'll evaluate the you know, the angles and everything like that we're playing with, and we'll see how that sort of just works out, I guess. But I'm going to call it there, and we'll start off the next episode where we get into basically the designing of that. We start to talk about engine basically positioning, the relevance of it and stuff like that, and why final drive line angling is such an important thing as we evaluate this. So anyway, thanks for watching, guys, and have a good one.